When the Duet 2 Wi-Fi controller turns on, a yellow LED light is powered to indicate that the different axes are not homed. I do this with Conditional G-Code, which I call into the Config.g file in the system directory. The lights are currently plugged into the PWM fan headers on the Duet 2 Wi-Fi. In this instance, I'm using fan header 0 for red, 1 for yellow and 2 for warm white. Once all the axes are homed and not before, does the yellow LED light turn off and the warm white LED light turn on. When in situ, the warm white LED light will be under the gantry of my CNC machine and will be used to illuminate the wasteboard. These LED lights accept a maximum of 12 volts, so I have to be careful when I write the code not to send the full 24 volts through the pins. I also haven't quite worked out how to write a piece of conditional G-code to turn the red light on while running a job. So for that, I simply put the correct code into my starting and stopping scripts. That big clunky thing is a prototype for a DIY tangential knife head. Mechanically it works, but I haven't worked out how to control it during a job. I suspect I'll make a video about that separately. Since my earlier experiment with the LED lights, I decided to get a 24 volt RGBWW LED strip and to install that onto the heat terminals of the Duex 5 expansion board. I'm doing this because all but 2 PWM fan headers on the Duet 2 Wi-Fi and all on the Duex expansion board temporarily turn on upon reset. This is a hardware feature, and as I was informed by a user called Bearer on the Duet forum, fan header 0 and 2 have pull down resistors on the gate to ensure they remain off unless driven, but the others are normally for hot end fans, so that behavior is a safety feature which would otherwise cool the hot end fan if the system is reset and somehow prevented from reading the config file, as the fan would remain on. In this instance, we just see the LED flashing. It doesn't look particularly great if lights flash randomly when any piece of electronics turns on, so I'm going to move this over to the heat terminals now. Okay, so I'm just going to show you how I'm going to wire this up. And the first thing I'm going to do is cut a piece of wire into 4 equal sections. I'm using a common anode LED strip, which are more common and can be connected directly to the controller. The black wire goes to the voltage in terminals via a small section of terminal block, and the other white, blue, red and green wires go to the various grounds. I'll be using heat terminal E2, E3, E4 and E5, which are PWM enabled, so I'll be able to control the brightness of the LED lights. Now that's wired in. So these different colour wires, the green, red, blue and white, may not correspond with the colours on the LED, so it depends where you buy them and so on. After wiring everything up, I can reboot the controller and we can see that the lights don't flash. I'm now going to update my Config.g file to include the terminal pins associated with the new LED strip. Okay, here goes. So this is the web interface that I'm using. In the system files I can go to my config file, and there's quite a bit of stuff here. I'll talk about this in more detail in different videos, but the bit that I'm going to work on is this section, which is to do with the LED strips. So I'm going to ignore these 3 up here, and then I'm going to change the settings for these ones here, and I'm swapping from the Duex.fan3 to fan 6 headers, and I'm going to use the E2 heater, and this one will be the E3 heater, E4 heater, E5, and you can only go up to 9 in this case. I don't know what colors these correspond to, so I'm going to delete these and I'll check these in a second. So I'll just describe quickly what these commands do. So M950 has to be used to set a port up. So essentially, if I don't have this command written in the config file without specifying the pin, that pin won't be used for the most part, unless I've enabled it with another command that might refer to something else. Once that's created, I can then control it using the M42 command, which is the switch IO pin. The P number refers to a kind of quick reference to what is being referred to in the pin. It's like a shortcut. An S sets the pin either on or off, and if it's a PWM enabled terminal, you can then go through all the varying voltages that are available. So in my case, I'm using a 24 volt power supply to power the control board, and the maximum volt that can come out of these headers is 24 volts. If I write S0.5, it should be 12 volts, although do check it with a voltmeter. Found that it's not exactly, doesn't exactly correspond like that. So now I'm going to save this, and then I'm going to check P6 to P9 to see what colors they correspond to. And just to make a note that I'm using the latest version of the RepRap firmware, which is 3.01 RC6. So it's a little bit different from version 2, where you have to define the pins by their names. If I drag the overview, this is the RepRap firmware version 3 overview, you can see the pin names for the Duet 2 Wi-Fi and the Duex, and this is what you're referring to, and these correspond with the diagrams. So in this case, this is the expansion board, and E2 heater defined like that, Duex.E2 heater, or heat, sorry. You kind of got to use your imagination with how these are written and what information is available on the diagram. I've not seen an overlay between the diagram of the boards and the pin names. Okay, so M42P6 S0.1, and that is green, so I'll write a note to that. I'm going to turn that off with an S0. Then P7.1, that is white. P8.1, it's red. P9.1, oops, is blue. So to make yellow, it's green and red. P6S.1. In fact, I can just go direct to full brightness so you can see what that's like, but I'll keep it low so we don't dazzle. And red, so P8, and that is supposedly yellow. It's not a great yellow, this is a better yellow here, but this is a dedicated yellow LED. So I wonder if you can get these things made up so they have the wavelength of light that you actually want. So the other thing I have in my config file all the way down here is a P98 command, which refers to a conditional 1.g macro file, which is where I've written a piece of conditional code. And I'm now going to show you the updated Conditional G-Code, which controls the LED light strip plugged into the Duex expansion board. It's based on an example in the G-Code meta commands page on the Duet website. I start with setting all the headers controlling the LED lights to off with the M42 and S0 commands. I then write a conditional construct starting with if followed by 'move.axes0.homed with 2 vertical lines, and then followed by pretty much the same text but a different number which corresponds to the different axes. The behavior works in the following way. If axes 0, 1, 2 and 3 are not homed, turn on the yellow LEDs, else turn on the white LEDs. And I found I had to write it this way so that all 4 axes had to be homed before the warm white LEDs are turned on. The apostrophe means a boolean not, which is a logical prefix operator and inverts the upcoming inquiry. I think it's an inquiry, I don't really know what the right terms are. I'm still getting my head around this type of programming, but the next thing I want to do is either write a new conditional script or expand the current one to detect when a job is running so the red LED turns on and the other LED lights turn off. So I don't have to either use the post processor in Vectrix to write M42 commands in the G-Code script, or what I actually do, which is write the M42 commands in the start, stop and pause.g macros in the Duet system files. So that's how I installed the LEDs onto the Duet 2 Wi-Fi and the Duex expansion board, and the example of conditional G-code I've used to control them. I'm going to leave this video here and I hope you found that interesting. Please remember to sacrifice a thumb, and if you haven't done so already, subscribe and press the bell button for notifications of new videos. Thanks again for watching, and you'll catch me in the next one.